In today's lesson, we will continue with problem solving, and this is part 2, which focuses on all types of questions relating to the distance formula, which is distance equals rate times time. We will look at two different scenarios. First, two vehicles that travel in opposite directions. And then we'll look at two vehicles that are traveling in the same direction but leaving at different times. Here is our first story problem, and it is involving direction opposite. So two things are moving in opposite directions. At 8 a.m., a car leaves a house at a rate of 50 miles per hour. At the same rate, another car leaves the same house at a rate of 45 miles per hour in the opposite direction. At what time will the two cars be 285 miles apart? And we want to always be aware of the formula distance equals rate times time. I'm going to draw a little picture that's going to explain what's going on in this story problem. Here we have a house. One car left and is leaving at 50 miles per hour. That is the rate. And then there's another car that leaves at the same time but is traveling in the opposite direction. And this car is traveling at 45 miles per hour. Now, when two cars are traveling in opposite directions, they are moving away from each other at a rate of 95 miles per hour because you add your two rates together. So make sure you make a little note to yourself. Traveling in opposite directions means that they're traveling at a rate away from each other at whatever the sum of their rates are together. So now let's take all of our information and plug it into this formula. So the two cars are traveling and they are 285 miles apart. That's my distance. And then my rate is their combined rate, 95 miles per hour, and we're solving for our time. So 285 equals 95t, and now we can solve for t, in which we can divide both sides by 95, and t equals 3 hours. And now there is a way to check your solution. You want to think about two different cars. One of them was traveling at 50 miles per hour for 3 hours, which means they traveled 150 miles. And then the other car, they were traveling 45 miles per hour for 3 hours, which means they traveled a distance of 135 miles. And then when you add these together, you should get that they were 285 miles apart. So it works. And I just realized that the question is asking at what time. So we solved that it's 3 hours, which means it's at what time. It's 3 hours after 8 a.m. So 9, 10, it is 11 a.m. is your actual solution. Here's our second story problem. This time we're looking at two trains that are traveling in the same direction. They're going to travel the same distance, but they have different rates, which means they will travel that distance at different times. So, a train leaves the station at 4 p.m., traveling west at 80 miles per hour. On a parallel track, a second train leaves the station 3 hours later, traveling west at 110 miles per hour. At what time will the second train catch up to the first? So, for these types of questions, when the direction is the same, I like to make the following chart. I have train 1 and train 2, and then I'm going to fill in information that I know about their distance, their rate, and their time. Well, train 1 is traveling at 80 miles per hour. And train 2 is traveling at a rate of 110 miles per hour. Now, this last line, when will the second catch up to the first? So, let's say this box is a train station. The first train leaves. The second train leaves from the same place just a time later, and we want to know when will the second train catch up to the first train. So if you notice, the distance is the same. So the distance that they travel is the same, but they have different rates. And now let's look at their times. The second train leaves 3 hours later. So that means there's going to be a difference of 3 hours between the two trains' times. And the faster train will travel that distance in less time. So, train 1 is going to travel for T hours, but train 2, because it's going faster, it's going to reach the same distance 3 hours less, because it left 3 hours later and it's traveling faster. So we want to know, when will this rate and time be equal to this rate and time, since the distance is the same? So I'm going to set these equal to each other, just like we have rate times time. When will that distance be equal to this distance? Rate times the time is t minus 3. And now we're going to solve for t. If we distribute, we have 110t minus 330. And now we can subtract 110t on both sides. And we are left with negative 30t equals negative 330. And then if we divide both sides by negative 30, we should get that t equals 11 hours. However, what they're asking is, at what time? So we have to think about when these two trains left and how long did it take them. If you look at train 1, they left at 4 p.m. And then t, if you look, corresponds to train 1. So 4 p.m. plus 11 hours later. You could also look at train 2. They left 3 hours later, so they left at 7 p.m. But their time was 3 hours less, so it only took them 8 hours. So now, 4 p.m. plus 11 hours, or 7 p.m. plus 8 hours, both of them will give you the time of 3 o'clock a.m. So that is the time that it takes train 2 to catch up to train 1. That's what time they will meet up. So this is a very complicated type of problem, so really take your time and really think about everything that's going on. And good luck with the lesson. Let me know if you have any questions.